Hi, everybody. This is MT Turtle. I'm here with Happy Face, and this is No Mind Radio. I'm glad you're here with us, and today we are talking about how we had a smaller Earth back in the day. Happy Face, can you explain how we had a smaller Earth?
I think that's remarkable that we could have a topic about a smaller Earth because it could fit all the facts, every single other fact more or less, together into a story. Interesting, I know this morning, when I saw you, you reckoned that there was a 32,400-year-old woolly rhino that was found.
Yes.
Yes. It's interesting because it probably would be in the Siberian frosted sort of area where that is Siberia, because what this just melted out of the ice.
Who knows what happened?
Yeah, well, I reckon that it's just melted, hasn't it? But so it's fresh.
I'm not sure what the details are, but.
Well, they have had lots of these things coming out of the permafrost as they melt, and it's as fresh as the day it was preserved there.
That is very interesting.
Yeah, because in some of these circumstances, they'll even find daisy cups, flowers, in the midst of chewing.
Wow! So you would say that they were quickly frozen?
Well, it's an amazing thing that when you look around the Earth, you see snap done. It's kind of like a picture of something sort of in agony a little, but snap done, yeah? So they're not taking a long time for that to happen. But in the idea of a smaller Earth, of course, you've got to have a catastrophe, and you've got to include catastrophe. So you can't be looking at time constant, in fact, at all, and that there's been quite a lot of variation and things going on, but even including something that would be really snap done. But could you imagine just for a moment that the Earth, it's moving around from west to east, right? And as it's rolling along, we've got an atmosphere, and it's pretty thin, when you look at it. Our atmosphere, just hugging the Earth a bit, like really thin. And it's an amazing thing that, could you see that it's not really sticking to the Earth? Could the Earth slip inside that?
I would say yes.
Okay, yeah. So it's really got a dragging kind of a bulking constant, but if suddenly it goes beyond that stick constant to a slip constant, it could slip, and the Earth could slip around, which it does, yes, and it doesn't hold the atmosphere close to it as much, yeah, in that time. And so how cold is it at 10,000 degrees up there?
That is a great question. I haven't made it that.
No, yeah, but it's pretty cold if you go up there.
I would imagine so.
Yeah, it is. It's pretty friggin' cold. 10,000 feet can give you like a minute or more or something of free fall, a bit. You know what I mean? Quite nice. But you've got to have a bit of a suit and be pretty warm up there for that minute or so. You're really a bit cold when you jump out up there.
Okay.
But of course, the woolly rhino. Look, it's 32,400 years, and it's interesting that they carbon-14 those things, and they are different ages. In fact, some are more 12,000 sort of years, and they correlate with one of the sort of catastrophes somewhat, don't they? So it's sort of really, when you date things and it goes back and you can see a dating, it's kind of like that 32,400-year-old woolly suddenly in the permafrost snap froze, and it's got a really beautiful strawberry blonde thick coat, quite nice, but it's actually a rhino. It's a rhino, mate.
A woolly rhino.
A woolly rhino in the permafrost. But those things get exposed, and they're sort of like a popsicle, isn't it? Just popping out, but giving you deep insight into the past. And once you've carbon dated, of course, which it was, you've got facts. But you've got this short woolly hair. It's found really with tiny little small water fleas.
Yeah, and so I'm sure there's not only just the rhino, but all the little insects and these little foot water fleas, they're not really found anymore in that area. I mean, it really, maybe they lived up until that time in the past or whatever, but certainly, these that species that we've been talking about a bit, could it have certainly lived up to maybe 6,000 years ago only, or less, or maybe more into even recent time, but got extinct in that moment. So not everything sort of all of a sudden got wham bam thank you ma'am sort of thing, but that thing, species can have survived some, but then something like a huge snow over causes like worms not to be found necessarily, like earthworms sort of thing in the Antarctic, for instance. But could they have been there before this point? We don't know. But basically, you've got a fully adapted animal there that was found, the woolly rhinoceros, and it's 32,400 years ago. And it looks like it's been snap frozen. So obviously something occurred back then that was some sort of a planetary condition, or something that knocked the Earth, moved the Earth over. Because the Earth had to move, and it would have to have come close to 10,000 feet up. The Earth is... the air's cold, isn't it? Freezing. Mm-hmm. So the Earth suddenly touches some of that air, that Earth. It comes down to ground level as the Earth moves, you see, because at the equator you're 17 kilometres or more out into the sky than you are at the North Pole, sort of thing, yes? Because you're further out. It's pushed out at the equator and more flattened a bit at the poles. So when the Earth shifts over like that, you can see suddenly an altitude of 10,000 feet coming to exist at ground level quickly, snap, done, right? Okay.
And if it were done, that would explain fast snap frozenness. You understand?
Yes, I do.
Okay.
Trying to hang
penguins back then, I mean, we've found penguins at the Antarctic, and they're about 7 feet tall.
What?
Yeah, about 250 pounds.
And when was this?
And they could live underwater for 45 minutes or more. These,
wow.
No problem at all.
So we're talking like,
and they lived. They were 800-year-old penguins.
Wow.
So you could imagine that. Of course, we've still got animals that could live a long time, like some of these turtles.
I've heard of sharks living a long time. But
we've got sharks as living as they're as old as Henry VIII.
That's just amazing to even comprehend that.
Yeah, in the ocean,
let me ask you, so the Earth is how many miles around now? A few thousand, right? But you're saying that at one point it was way smaller.
Yeah, that's right, Will. Well, when you fit all the continents together, there is no need for subduction.
Okay.
There is no moving of plates around. None.
No.
Hold on. And if you go back, you can see all the continents. It's at 35 mile thick on average, all fit together exactly, Caesar, okay? So if you have a theory about anything, then you must bring this fact in, okay? And so now you've got what to do, you see. This is a totality. It is not a theory. It's a quanta. Okay, because if you could go back and you could see that a hammer was encased in stone, yes? Mm-hmm. Well, first you'd know that the hammer was older than the stone, wouldn't you?
If it was encased in stone, you would suspect that.
Yeah, that's right. But we couldn't expect that it would be very old, maybe, because it could just take a second for a stone to form around a hammer. You see?
Is that right?
That's right. And matter of fact, wood could become stone an instant more, as you know. But it was a time when the mountains really were levelled, you see. They were we were all snowballed. And there was an unconformity, you see, meaning like something just gets erased. You see, so what do you do about time frame where that is? Because you've got no record. It's like you've got the pages of a book and somebody came along and actually took the vast majority of all the pages out of there. Mm-hmm. You see? So these are the kinds of things that you've got going on where escarpment is and this sort of thing. But when you look at a smaller Earth, you can see that all the plates fit exactly back together in a smaller Earth. So your quanta in a totality, or anyone else's, must describe what that is first. And you can... that every time an asteroid hit, it boiled water and it caused water to come out of its maximal loading state at 42 degrees Fahrenheit on average, where things are. And then if it gets below that or above it, it can expand 1,700 times as a gas. So let's not say that there's nothing pressurized. There sure is. And every time you have an asteroid come in, it unlocks water. And guess what? We've only got a little bit of water now. That's the oceans, that's all. But we didn't have any before when we were small Earth, just like two lakes, Lake Victoria and the Mediterranean, which does have an 85,000-year-old sort of bottom and things. And you could see that went through stages of drying out and this sort of thing. But you've got... a smaller Earth where all the continents fit together, and you've got a sea plate floor now, 5 miles thick, and it's dense magma, and it pushes and expands, and that sea floor is growing. Yes, it is. But did the continents grow? No. Continents got pushed apart by these sea plates, which have grown in the middle. And so when you boil water with an asteroid suddenly here, you're going to expand the surface a lot, which it is, 12 times larger than it was. You know, when we used to be part of this constellation of Saturn before we became connected more to the solar system, we only had a black sun. So we had a different sort of a sun.
Okay, so the seafloor is the evidence you're saying that we expanded into the size that we are now.
Mm-hmm. Yeah,
from
the
a smaller
expansion
planet,
that's right.
From smaller Earth.
Yep. And explaining how that happened through water having expanded. That's correct. Okay. So you don't have to have a calculation of a mass all of a sudden, more or something. It's like, no, you actually have an expandedness. Yes?
That's
so there's plenty of materials that expand when water gets to it, right?
Sure.
So what about like bentonite? Yes?
What about
bentonite is a clay, which you let a little water come to that, and it is going to expand like crazy. That's right. It'll crack the earth even, which is being used for fracking and stuff. You see? Yeah. So you've got things which really expand, incredible. You see, once they're mixed with water and that sort of thing.
Okay. Now, and with that, would you say that the Earth is going to continue to expand?
Well, every time an asteroid comes, of course, it certainly does.
Okay.
Absolutely. So the question is, would it expand more again? Yes, I'd say so. Why? Well, because we'd be due in some time again for an asteroid, because over the last 85,000 years, at least the evidence of some 300 asteroids have hit.
Well, that is fascinating.
Yeah, that's right. And that shaping things, which some of these things only happen once, that's it. Not like, they're going to happen again. But, for instance, planetary alignment of things, when that does happen and did happen, it's now done. That's in the past. But it was only one moment in time and things that occurred and that, you see? Yeah?
Well, that is just amazing that we came from a smaller planet. Now we're at this current size, and the chances are the planet might even get bigger.
Well, imagine just for a moment that you've got a hammer and a feather. Okay. A hammer weighs a lot and a feather weighs nothing. Can you see them floating together in an inverse gravitational field?
inverse gravitational field? Sure, why not?
Well, how's that? Something is so damn heavy, but you can just like as light as a bloody feather. The feather is light as the hammer. Okay, you must understand these things. Not an equal and opposite reactedness necessarily, like what Newton thought of some uniformity per se, but something exists with a variableness that really can magnetically be of a shifted static magnetic field in relation to some dynamic field that could take place where that is and things. And gravity really is just a pull of magnicity toward the Earth more from a larger object bit, like 23 pounds or whatever it is, like of atmosphere that's pressing down on us. It's really that you could look and see life colloid, for instance, transmutate from one element into another, which is not anything anybody maybe knew, but like when you look into space, I'm not saying just look at space, but what's inside space down to the quadrillionth of a unit, you see, of a light unit. But look, could you see that there's a lot of material there? Of course. It doesn't just stop after hydrogen, you see. You've got element which is hydrogen is made of. And so where you have two light waves phase conjugated with each other, equal and opposite basic, but you've got a little difference. It's that difference is a residuum, and that is a Jubb constant. And that is based in physics. It's the smallest pixelated dot, in fact, you see, yes?
So the smallest known element?
Yeah. And so dark, might you know, is 10,000 times much faster than light. Of course, light is a really slow slug, okay? So you've got to know that processing it is going to be faster than the speed of light processing itself, you see. A wave of magneticity going up and down can be going 10,000 times faster than light, you see. So dark is 10,000 times faster than what light is. Light comes out of dark, you see, yes, not the other way around. And we're falling behind the sun, as we talked a bit about, in a spiral behind the sun sort of thing, along with the other planets all spiraling behind. No one gets in front of the sun at all. It's just falling at 450,000 miles an hour sort of thing, and we're in a curl-back region there. Other galactic systems in our universe really exist that where you're on a ship and travelling at 450,000 miles an hour and you could be playing a game of cards, because you're getting frame dragged along. Nothing's going on in the ship. It's not changing its acceleration or anything. You're not even knowledgeable that it's going 450,000 miles an hour, except for all the little particles around you, be constant state of like massive movement, you see, because of it. You've got, water out there in the universe, and you've got a JC quanta of a loading point where things are, which is really a quanta that's 42 degrees Fahrenheit or 34 degrees Celsius. It really expands and above and below that point. And basically you've got a water that's H3O2, you see, which is really structured and very functionally plastic, and that's existing sort of really to hold a memory. And primarily when your body's really just only fall 5% below what it should have in your body, you have sickness. It's quite incredible, matter of fact. Very important that you have H3O2, which is there's 3 types of water. This is a gel state water, which life hydrate makes. But you basically say that out of the random background, something non-random suddenly appears, Caesar. There's a mountain of evidence, MT, really, that you're climbing, that you can't just sit around and look at. You see, you've got a galaxy that's spinning, but you can see spiral arms are right there, aren't there? And it's spinning faster on the outside, isn't it, than it is more on the inside. And you've got a magneton, basically particle, it's positive, negative, and neutral. That's it, really, in a JC quanta. And you've got, if you go down to a quanta where this is, where a beetle can get a steady state kick off in flight, you're going down to 10 to the minus 10 to the minus 71 centimetres, you see, per squared cube. And down there, that's how far down you've gone. It's into a quadrillion light units in a second, basically. And so it's really looking at, if you look at how many stars kind of would have blown up in all this time, apparently, you know. But what's the reason why you can only find maybe 300 fragments left? That can't be right, you see. But it's true, lots of stars get blown up, but it is that they just get disappeared after a moment of time, and where do you find the material of it? That's right. Things like a river that you've walked into, the water of it you could pass through, and always it's a different stroke of water when you pass through the river, you see. And like, for instance, Sirius, that we talked about in the last program, used to be like seen as a red star, but now like is looked as a white dwarf. And the planet Jupiter, well, could you say it's a long time, because like it's just cooling down. It's cooling down. So, you know, all of a sudden there wouldn't be anything to cool down to if it was a long time, you see. So I'm just saying that it's much different, a smaller time frame, and all the millions of years old doesn't really work where the radio isotopes are, and you know, those being clocks aren't reliable whatsoever at all, you see, in a time frame. And many, because all those radioactive isotopes can only go off in 1 million years or more, but the accuracy more is to understand that we've got tissue and everything, soft tissue and all this sort of thing that's been dated, and that's not too old, really, you see? Yes?
Well, I'm trying to keep up here because you're talking about a lot of stuff that I'm just hearing for the first time. And, I mean, it's all just fascinating. I'm trying to not get my mind blown right now, you know, I'm trying to keep up. But let me ask you, Sirius, you were saying that it's what kind of star is it?
It used to be known as a red star.
Okay.
But it's now a white star, so it could have these things being changed because, like, just like Jupiter's cooling down, what really that's going on today, you really back out there further away, it take a long time for that information to come to us. And what we're seeing today only happened 1 million years ago if you're looking at light.
Now,
but we could see beyond light, and that's what we should do with telescopes.
Well, let me ask you with Sirius, is that the closest star to us?
Yeah, the dog star Sirius is in the same parental tidal pool as us, and we are doing a figure eight with each other. As it takes 26,000 years basic to move around in one circle, sort of, around Alcyone. And the dog star Sirius is like our figure eight type of others, sun going with us as we're going around. They all go in pairs, look out, and you can see it, in fact, you know, mostly. Saturn's rings, Earth can have had rings in a time gone by, but Earth is only maybe 1/90th or less or something, you know, of Saturn. It's huge.
Well, I heard Saturn's rings will eventually fade away.
Yeah, well, they are. Only just that you could see that water was out there and ice and what have you, and chunks and stuff. If you add it all up, you could see that it could have been equivalent to 2 moons that smacked into each other a bit, you see, and this sort of a thing. The moon, when it came close or comes close, it sort of really affects the tides and causes the tides to be far greater. When planets come close, sure does as well, like the Exodus in 1500 BC. Planets were coming close to us, in fact, and they sure did pull the tides massively and pulled all the oceans away and left the bottom of them, dry.
Well, they say timing is everything.
Well, it was an amazing thing that, you know, someone could kind of really be aware more, you know, of various things. You could see these things and people really did know, this is going to maybe happen, you see. Not maybe, but could calculate. And even today, But there's a lot of slippery slope because people could think that something existed, but there's not a fact to support that. And so that's called slippery slope, you know.
Something exists, but they don't have a fact to support
that's
it.
Right. And so bandwagon is like where popular has got we've got a big bang, and that's ridiculous. The idea that we got a big bang, and that's actually what caused elements to form. It's like, oh my God, this is just crazy.
So you're saying that the Big Bang Theory is incorrect?
Well, when you haven't looked inside, how could you look out to find a big bang when you're talking about looking inside to see how magnetic domains isotonically can be brought together so an element is transformed with a vacuum and pressure isotonics, you see, which happens in nature. But like the Oort cloud is a little bit of a slippery slope because everybody would be talked a bit about it, but no real proper observational reference point exists, you know. And a lot of things could be just sort of talked about because it sort of can't sort of be seen so far away, but yet and hasn't been sort of observed necessarily. But dinosaurs can't be very old, can they? Because you've got really scientific observation that the extinction really wasn't very far, not long ago, because you've got soft tissue, you've got all the red blood corpuscle, you've got all this sort of thing that's being found in cells. And it was only like in about 1841, if you go and have another little bit of a look, that these things were called dragons.
Okay.
Just dragons.
Now we're really getting into it with a lot of listeners, I'm sure. You're saying to our listeners that dragons existed?
Well, what existed was our explanation of things to be only considered to be a dragon, you know. A dragon, but we did, have experiences of things we couldn't necessarily really name or something, you know, and I guess we call them dragons.
So breaking down dragon, what does that mean originally?
Oh, a dragon, probably sort of like an idea of a reptile, probably, usually, because it's sort of a scaly animal, but typically they've got tails as really thick as cedars, so you got to think this is definitely a dinosaur.
Why did they give it a name, dragon?
Oh, a drag on. It would be a bit of a dragged-on story somebody could have. You know what I mean?
Yes.
And a dragon was like something fictional, mythical to some degree. Yes, it could fit something mythical. So, you know, you could have
a good name.
Yeah, well, yeah, dragon. Yeah, gone that's dragged.
Okay.
But guns blaze, of course, to shut evidence down, like, and a claim, of course, like this is. But where everything else is sort of just maybe some complaint about something basic, but not any claim per se, you see. But based on presupposition and things, somewhat. But could you have something where the fact all fits, which you do now, that you could say, okay, we did have a smaller Earth, you see? Yes? So I'd say that's probably one of the more important things. In fact, it can then cause you to consider a lot of other things. And so, for instance, the Appalachian Mountains, and the Atlas Mountains and the Scottish Highland Mountains were all together in a smaller Earth. Now they've been pushed apart, but they were from the same mountain range.
Wow.
Do you see what I mean?
Yeah.
Yeah? So the proximate nature of where things were before the seafloor grew is really something.
Well, I tell you what, just in these a few minutes, I've really learned a lot. My mind is blown, folks. I'm trying to keep up. Happy Face is at a few levels, if not all levels, higher than what I'm used to. We're going to call it a show today. I appreciate y'all being here. As you can see, we have plenty more to talk about. Stay tuned, and hopefully on the next one, we'll blow your mind.